Aren't they some good looking images? And even better that they're from our own custom dataset. Now we've got one more step. We're going to turn our dataset into a data loader. In other words, we're going to batchify all of our images so they can be used with a model. And I gave you the challenge of trying this out yourself in the last video, so I hope you gave that a go, but let's see what that might look like in here. So I'm going to go 5.4. Let's go, what should we call this? So turn custom loaded images into data loaders. So this is just goes to show that we can write our own custom dataset class and we can still use it with PyTorch's data loader. So let's go from utils, torch.utils, that is, utils.data, import data loader. We'll get that in here. We don't need to do that again, but I'm just doing it for completeness. So we're going to set this to train data loader custom, and I'm going to create an instance of data loader here. And then inside, I'm going to pass the data set, which is going to be train data custom. I'm just going to set a universal parameter here in capitals for batch size equals 32, because we can come down here, we can set the batch size. We're going to set this equal to 32, or in other words, the batch size parameter we set up there. We can set the number of workers here as well. If you set to 0, let's go see what the default is actually. Torch, utils, data, loader. What's the default for number of workers? 0. Okay, beautiful. And recall that number of workers is going to set how many cores load your data with a data loader, and generally higher is better. But you can also experiment with this value and see what value suits your model and your hardware the best. So just keep in mind that number of workers is going to alter how much compute your hardware that you're running your code on uses to load your data. So by default, it's set to 0. And then we're going to shuffle the training data. Wonderful. And let's do the same for the test data loader. We'll create test data loader custom, and I'm going to create a new instance. So let me make a few code cells here of data loader. I'm going to create a data set, or pass in the dataset parameter as the test data custom. So again, these datasets are what we've created using our own custom dataset class. We're going to set the batch size equal to batch size, and let's set the num workers equal to 0. In a previous video, we've also set it to CPU count. You can also set it to 1. You can hard code it to 4. All depends on what hardware you're using. I like to use os.cpu count. And then we're not going to shuffle the test data. False. Beautiful. And let's have a look at what we get here. Train data loader custom and test data loader custom. And actually, I'm just going to reset this. Instead of being OS CPU count, I'm going to put it back to 0, just so we've got it in line with the one above. And of course, num workers, we could also set this num workers equals 0 or os.cpu count. And then we could come down here and set this as num workers and num workers. And let's have a look to see if it works. Oh, beautiful. So we've got two instances of utils.data.data loader. Now let's just get a single sample from the train data loader here, just to make sure the image shape and batch size is correct. Get image and label from custom data loader. We want image custom, and I'm going to go label custom equals next, and I'm going to iter over the train data loader custom. And then let's go print out the shapes. We want image custom dot shape and label custom. Do we get a shape here? Beautiful, there we go. So we have a shape here of 32 because that is our batch size. Then we have 3 color channels, 64, 64, which is in line with what? Which is in line with our transform that we set all the way up here. Transform, we transform our image. You may want to change that to something different depending on the model you're using, depending on how much data you want to be comprised within your image. Recall, generally a larger image size encodes more information. And this is all coming from our original image folder custom dataset class. So look at us go. And I mean, this is a lot of code here, or a fair bit of code, right? But you could think of this as like you write it once, and then if your data set continues to be in this format, well, you can use this over and over again. So you might put this image folder custom into a helper function file over here, such as dataset.py or something like that. And then you could call it in future code instead of rewriting it all the time. And so that's just exactly what PyTorch has done with torchvision.datasets.image folder. So we've got some shapes here, and if we wanted to change the batch size, what do? We just change it like that. 64. Remember, a good batch size is also a multiple of 8 because that's going to help out computing. And batch size equals 1. We get a batch size equal of 1. Whew. We've been through a fair bit, but we've covered a very important thing, and that is loading your own data with a custom data set. So generally, you will be able to load your own data with an existing data loading function or dataset function from one of the Torch domain libraries, such as Torch Audio, Torch Text, Torch Vision, Torch Rec, and later on when it's out of beta, Torch Data. But if you need to create your own custom one, well, you can subclass torch.utils.data.dataset and then add your own functionality to it. So let's keep pushing forward. Previously, we touched a little bit on transforming data, and you may have heard me say that Torch Vision transforms can be used for data augmentation. And if you haven't, that is what the documentation says here. But data augmentation is manipulating our images in some way, shape, or form so that we can artificially increase the diversity of our training data set. So let's have a look at that more in the next video. I'll see you there.